Here we are. I'm going to go ahead and work on problem number 5 from our Unit 3B review. I've got my picture already plotted out. I've got some quadrilateral shape ABCD with diagonals AC and BD drawn in orange. So we're supposed to find the lengths of those diagonals. Now keep in mind, you can always use the distance formula, which as a reminder is distance is equal to a giant square root sign of x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. That will always work for you to go between 2 points on the coordinate system. However, we're going to go with kind of this right triangle approach that a lot of us have been adopting. So I'm going to work on AC. Let's go ahead and do that first. So now I'm going over to my picture and I'm noticing that if this were to turn into a right triangle, this would be one side right here with a length of 2, and then traveling over, that would be a length of 1, 2, 3, and 4, creating that right triangle that we talked about. That means that the hypotenuse I want is our diagonal AC. So I'm going to go ahead and work with our 2 legs. So we have 2 squared plus 4 squared is equal to the hypotenuse that we want squared. We're going to go ahead and simplify this to 4 plus 16 is equal to x squared. Combine those, you're going to get 20 is equal to x squared. Now to undo that squaring action, we're going to go ahead and take the square root. So that means that x is equal to the square root of 20. Now remember, at this stage, we're going to want to practice leaving this in simplified radical form. So I'm going to go ahead and bring that work up here. For that, you want to take your number and start breaking it down into its factors. So some people might think 20, well, that's 2 times 10. 10, well, that's 2 times 5. And then at that point, you go ahead and stop, because neither of these are going to continue to factor beyond that number times 1. So that means that x is actually equal to the square root of those factors. So 2 times 5. And if you notice that you in fact have a pair, that means that one of them can come out, and that entire pair goes away. So that means that AC is actually 2 root 5. Now I'm going to go ahead and work on BD, but I'm going to do it over in this available section. So here is BD. I'm going back up here to my picture, and I'm noticing that if this were to turn into a right triangle, it has legs of length 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. That was 8, and this was 4. Okay, so we're going to go through that same process. So the leg of 4 squared plus the other leg of 8 squared is equal to that hypotenuse, diagonal BD, that unknown length squared. Go through the motions. Remember that 4 squared equals 4 times 4, not 4 times 2. So that's 16 plus 64 is equal to x squared. We're going to combine those together to make 80 equal to x squared, which we undo that by doing the square root of both sides. And that means that x must be equal to the square root of 80. Now, since I'm supposed to leave this in simplest radical form, let me bring my work over here. I'm going to go ahead and break down 80 the only way I know how. So 80 nicely breaks down to 2 times 40. 40 breaks down to 2 times 20. 20 breaks down to, 2 times 10. And then 10 breaks down to 2 times 5. Quite a lot of factors there, so you want to make sure that you keep yourself organized. So that means that our x value is equal to the square root of the multiplication of those factors. 2 times 2 times 2 times 2 times 5. We have a couple pairs, so you circle up one of those pairs, which means a 2 can come out, and that pair is gone. You'll notice that we have another pair of 2's here, which means that one of those can also come out, and that pair is gone. And that means that we're left with 2 times 2 on the outside, which makes 4, root 5. So here is our length of, of BD. Sorry about that, got a little excited. And here's our length of AC. Now, it says to find the area of the rhombus. I hope you remember that the area of a rhombus, this is one of those ones that deals with those diagonals that we just found, the area is equal to 1/2 the quantity of diagonal 1 times diagonal 2. Well, we have both of those pieces of information, so we're just going to drop them in. So this is equal to 1/2 times diagonal 1, 2 root 5, times diagonal 2, 4 root 5. Looks a little bit tricky, but it doesn't have to be. Remember, with these expressions, the 2 and the 4 on the outside, they get to multiply with each other. So I could actually rewrite this as 1/2 the quantity of 2 times 4. And then don't forget, you still have a multiplication of root 5 times root 5. This simplifies further to 1/2. 2 times 4 is 8. Now remember, root 5 times root 5 really just means the square root of 25, which breaks down nicely to 5. So this then equals 1/2. 8 times 5 makes 40. 1/2 of 40 works out nicely to 20. And since it's an area question, we're going to go ahead and leave it as units squared. Alrighty, thanks for watching.